Good day, everybody, and you're most welcome to today's presentation of the CNPS. It's one of our alternative technical sessions that we hold fortnightly at present. Actually, we are looking at increasing the frequency to weekly, and in fact, our speaker today is one of the candidates we're looking at to take over as hosting. On the alternate weeks that I'm not available, but we can look into that later. There were some problems with the audio. There may be one or two teething problems, so you'll bear with us when we hand over to Roger if there is any problem. But I'm delighted to introduce again Roger, who has spoken to us fairly recently, actually, on a number of occasions, and he's been involved in the dissident community for quite a number of years. Roger's from England, and today's talk is entitled Einstein's Relativity and the Scientific Method. And he says that as part of the scientific method, a theory can be modified to sort out its problems. In the case of relativity, too many modifications were needed. Now, that may seem not too surprising to many of us, but I think he's making quite a radical suggestion from that. He's saying that this whole business has led to the very failure of the scientific method. So I think Roger's thesis is that Einstein's relativity needed a lot of modifications because a lot of things that Einstein said he got wrong. As part of the scientific method, a theory can be modified to sort out its problems. Yes. In the case of Einstein's relativity, too many modifications were needed, and that leaves it confusing as to what the theory is supposed to now be, right? With some people believing one thing about relativity and other people believing something else. For instance, some people believe that Einstein's relativity is a relativity theory, while other people believe calling it a relativity is a misnomer. This confusing mess has resulted in a failure of the scientific method. Well, that seems quite a radical proposition to many of us. So we can. Roger can hear us now, which is good. He sorted out his audio problem because I was afraid that we might have some problems. There's some comments coming in now. Okay. So there are people logging in now to the social media, and I'll be looking at their comments. Now, there are quite a number of people in the green room. They've obviously learned how to get into the green room because I haven't seen them before in the green room. But we'll talk to them later. I'll introduce them and ask them to come up and say a few words about the presentation. Roger has quite a number of slides, but he's always very efficient in getting through them. He doesn't dwell very, very much on any one slide, so he has quite a bit of visual aiding there, and we'll deal with them now. Is there anything else I have to? Well, yeah. So just in case for the new people, my name is Ian Cowan from Ireland, and I'm hosting the meetings every alternate week at the moment, every alternate Saturday, every second Saturday. And as I say, we're looking for maybe people to volunteer. Actually, as I say, Roger himself has volunteered, and we're hoping to have him set up with privileges to operate the system as I am, so he can fill in on the other weeks. Okay. So I'm going to bring Roger up now, and just hope that the audio is operational. Roger, you tell me that you can hear me. We can certainly hear you.
You can hear me. Good.
Yeah, there was some problem. I don't know what it was, but at least we can
it's
hear
setting
you.
itself up, isn't it? To begin with.
Yeah, you always
coming
have
in and out again.
Yeah.
Yeah.
And we're only at the beginning of a process if we have to give you further privileges. Yeah. But anyway, we'll worry about that.
Scary stuff.
Yeah, you're right. It's intimidating anyway. Okay, so with regard to the slides, you have quite a number of slides here.
Yes.
I think the last time you asked me to put them up, so
you just
need to tell me when to put them up.
If you try to give the screen to me, I'll try to put it up.
So, do you see present at the bottom of your screen in a banner?
Present, right. Okay.
If you click that, you should have the screen.
Share screen.
Yeah, share screen, exactly.
Yeah.
Let's see, does this work? You might have to say share what. It could be your slides, it could be your desktop.
Entire screen.
You could share the screen, or if you have them somewhere, like on your desk, you could just say share the slides on at this location.
Oh.
Yeah, no. I see them here, so I think I have to put them up. So
okay.
Let's see. Yeah, you've got now. So is that big enough for everybody? You may have to maximize that at the bottom right-hand corner of your own screen. Okay. I think I'm going to have to keep it that way because I want to look at the comments which are coming in. So I'm going to put myself down. But if there are any problems and you wish to raise that up, I'll have to come up again because otherwise I'll be silent.
Yeah. Okay.
And as usual, we will be giving a significant amount of time for Q&A and discussion at the end. So you needn't worry. Okay, let me see now. So I'm going to give the floor totally to you, Roger.
So you can see me, can you?
Yes, okay. Yes, we can see you on the left, and we can also see your slides.
Thank you for letting me give this talk. It's about Einstein's relativity. I think the way that Einstein has done things, it's caused the scientific method to not work. So next slide. Okay, good. So I blame this person below for the changes that he made, which has messed up the scientific method. So most of people in our group, Natural Philosophy Society, think Einstein's relativity is wrong, but we don't really seem to be getting anywhere with getting the physics establishment to change. And the reason is we don't really address the main problem, which I think is the scientific method has been messed up. So Einstein has changed a lot of things, and that doesn't really fit in with the scientific method. So the rough history is follows. It's 1905, Einstein does his paper on special relativity, and about 1908, Minkowski comes up with the idea of space-time, where you treat time as the fourth dimension, and that gets added on to Einstein's relativity. And then further on down the line, in 1950 and so forth, Einstein comes up with general relativity, which is about curved space-time and so forth. So it's lots of things get added to Einstein's relativity, and it's just sort of like a building process where more and more things keep getting added to it. So Einstein's relativity theory, which is both the special and general relativity, is not being presented as a completed theory, and is instead just something being built up. Where if you sort of like compare to what Newton did, he wrote a book, the Principia, and you pretty much get it set in stone what Newton's ideas are on lots of things. But with Einstein, it's sort of things keep changing. You're not getting a book from Einstein saying this is the definitive version of relativity. So you've got to bear that in mind now with the scientific method. So this is the flowchart for the scientific method, and people seem to start anywhere on the flowchart. But if you start for the making observations, you think of interesting questions, you formulate hypotheses, and you develop testable predictions, and then you test it, and if it works all right, you develop general theories, and so you just keep going on round and round in this ever decreasing circles. So Wikipedia gives the flowchart as this, and this is basically the scientific method. From observations, you are forming a theory from data you're collecting. So part of the screen is okay. Part of the screen I can't see. So the scientific method is an empirical method for acquiring knowledge that has characterized the development of science since at least the 17th century, with notable practitioners in previous centuries. And referring you to another article, it involves careful observations, applying rigorous skepticism about what is observed, given that cognitive assumptions can distort how one interprets the observation. It involves formulating hypotheses via induction based on such observations, the testability of hypotheses, experimental and the measurement-based statistical testing and so forth. And so on the face of it, it sounds all okay, but it's when you sort of add on what the way Einstein is doing thing, I think the thing just gets messed up. So next slide, and it seems to stop on me. Oh, right. So going back to this diagram, this is the flowchart which you're supposed to be using for the scientific method. So the failure starts when you get to this box. It's the refine, alter, expand, or reject hypotheses. And when relativity gets to that box, relativity just wants to move its goalposts, as I used to call it, where it makes amendments. And the people moving the goalposts are not telling everyone else, or hardly anybody else, what they did. So the goalposts are moving, things are getting changed about relativity, and they're not making it explicitly clear what they've changed. And then the process goes on around and around, moving the goalposts. And the theory becomes ambiguous and unfalsifiable because the theory just keeps getting altered. So this is my picture for the moving goalposts. When Einstein presented his theory, it was not a fully formed theory, and it just kept having things added to it, which is sort of the moving goalpost approach. So at that box, you've refine, alter, expand, reject hypotheses. Einstein's relativity is not a fixed, clearly defined theory. Instead, it's flexible and can be amended by add-ons and other things, like you can take ideas away and so forth. So Einstein's relativity needed a lot of modifications because a lot of the things that Einstein said he got wrong. As part of the scientific method, a theory can be modified to sort out its problems. And that is Einstein sort of like taking advantage of that bit. So you just kept making modifications to relativity too much. In the case of Einstein's relativity, too many modifications were needed, and that leaves it confusing as to what the theory is supposed to be now, with some people believing one thing about relativity and other people believing something else. For instance, some people believe that Einstein's relativity is a relativity theory, while other people believe that calling it relativity is a misnomer. So you've got too many different opinions as to what Einstein's relativity is. You can't even agree that it is a relativity theory. And this confusing mess has resulted in the failure of the scientific method. So let's look at an example of what was mentioned earlier. This is history again. Einstein's paper 1905, special relativity, about 1908, Minkowski, and that Minkowski space-time then gets added to Einstein's relativity. So we're applying Minkowski space-time to the famous twin paradox. We're ending up like diagrams, which is shown here for the stationary twin on the CT axis, and the travelling twin is going at this funny triangle shape. And that's supposed to give you when the twin stays at home and the twin travels off in their spaceship and then travels back to comes back to the twin at home, the twin at home has aged more than the twin that has travelled in the spaceship. And it's a diversion, but I would say aging effect is not really connected to the clocks being different, but let's pass on that. And it's basically what's being said for the twin paradox, that the twin that stayed at home has aged more than the twin that has travelled. So the relativity principle is sometimes stated as there's no preferred frame. So based on that, the clock dilation should be symmetric, each twin saying the other clock is slower. But with the Minkowski space-time analysis, the twin paradox, they're suddenly saying that the travelling twin has the slower clock, and both twins are agreeing to that. So I would say adding Minkowski space-time has added a preferred frame to special relativity. So it's like they're suddenly ignoring the relativity principle. Initially, special relativity 1905 has no preferred frame. Then from Minkowski space-time being added to it, it's kind of like they've suddenly added a preferred frame. So add the extra thing on to special relativity has made fundamental changes to what was initially being said. Also, in my view, adding Minkowski space-time has space-time as being like an ether. Thus, it's reintroducing ether, which seems contrary to Einstein saying initially in 1905. Of course, everybody's not going to agree to that. You sort of like you're having these changes, and people are sort of disagreeing about things. So people would, I've argued with lots of people about relativity, and some people would say, no, there's no preferred frame in Einstein's relativity, even when you add Minkowski space-time. But they don't really make sense to me when they're saying that the twins have their clocks different when they should be symmetric if it was going by the relativity principle. Anyway, moving on. So I say adding Minkowski space-time has added a preferred frame to special relativity, and sort of like people just don't necessarily agree with that. You've got a lot of disagreement in just when you're discussing relativity as to what people think relativity is. So when you get to this box in the flowchart, and so it's where Einstein's relativity is modified by an add-on, it leads to arguing where people are not agreeing to what the add-on means. That arguing is protecting Einstein's relativity as not agreeing to what relativity is. When it's in that box, you're not really being able to disprove it. You can't agree what the theory is, and you can't agree then to what would take to disprove the theory. So this is, for example, one person. He likes to give himself a nickname, Hammock Physicist, and he's one of the people who say that calling special relativity and relativity theory is a misnomer. And the way I would interpret that is he is tending to agree that Minkowski space-time has added a preferred frame to relativity. But as Hammock Physicist points out, not everybody's agreeing with his point of view on it. So he believes that special relativity is not a relativity theory, but you could get somebody else who claims believing in relativity, and they would say, oh, it is a relativity theory. So you've got these arguments going on all the time. So when you get to this box, not everyone is agreeing to what the modification to Einstein's relativity mean, and that just degenerates into arguments. Thus, arguments not being able to agree means Einstein's relativity has broken the scientific method. If you want to test a theory, you need to agree what the theory is. And if you can't agree what the theory is, you can't really test it. So when we get to Einstein, he said things like this. This is quoting Einstein. He says, "Since the mathematicians have invaded the theory of relativity, I do not understand it myself anymore." And when he said that, what he was referring to was Minkowski's space-time. When Minkowski's space-time was added to special relativity, he was saying, Einstein was saying he wasn't understanding the theory anymore. So it's not just me or other people not agreeing on what Minkowski's space-time has done to special relativity. Einstein was confused about it as well. And this is where I think the quote is from, explaining about Einstein giving this quote. And this is where Einstein says, "On one occasion, since the mathematicians invaded the theory of relativity, I do not understand it myself anymore." And it explains it there, what he was referring to as Minkowski. Right. So Minkowski got stuck as to what adding Minkowski's space-time to relativity meant. It needed clarification, but Einstein was confused about it. So, and the question becomes, and did Einstein provide adequate clarification? And the answer is no. So he was confused, and he's left it confusing as to what the Minkowski space-time has really done to special relativity. When you get to this box, not everyone is agreeing to what the modification to Einstein's relativity mean, and Einstein got stuck as well. And that's the breakdown of the scientific method by Einstein. He did not achieve that breakdown without help. He had the help of two influential philosophers of science to help him to break the scientific method. Now, the philosophy of science is really dealing with the philosophizing about the scientific method. So these philosophers were deciding, yeah, it's all right, Einstein can do what he does. And one of these philosophers is Popper. And he was a highly influential philosopher, and he came up with his philosophizing about falsification. You're supposed to ideally test a theory and decide whether you can falsify it. And he was very impressed with Einstein's relativity. So his philosophizing was based upon believing that Einstein had the right approach to physics. And so this is Popper's theory of falsification. So Popper believed that scientific knowledge is provisional, the best we can do at the moment. And he's known for his attempt to refute the classical positivist account of the scientific method by replacing induction with the falsification principle. So you've had these different philosophical approaches to the scientific method, and Popper was going against the classical positive account of the scientific method, and Popper came up with his falsification principle. And now all this sort of philosophizing helps Einstein to, Einstein's relativity to be ambiguous and have all its add-ons. This is a quote, and it's Karl Popper is prescriptive and describes what science should do, not how it actually behaves. So it's philosophizing of how science should be done, but when you get to the actual practice of science, scientists don't necessarily agree with what the philosophers say they should be doing, and they just ignore that and they do whatever they like anyway. So this is supposed to be the two methods of reasoning. You've got inductive reasoning and deductive reasoning. And so you're either starting from observation to get to a theory, or you're going from theory and trying to confirm it with observation. So all inductive evidence is limited. This is quoting, we do not observe the universe at all times and all places. We're not justified, therefore. I can't read the rest, things blocking on the screen. And according to Popper, scientific theory should make predictions that can be tested, and the theory should be rejected if these predictions are shown not to be correct. He argued that science would best progress using deductive reasoning as its primary emphasis, known as critical rationalism. And so he gives the following example. Europeans for thousands of years have observed millions of white swans. Using inductive evidence, we come at the theory that all swans are white. However, exploration of Australasia introduced Europeans to black swans. So Popper's point is thus this: no matter how many observations are made which confirm a theory, there is always the possibility that a future observation could refute it. Induction can't yield certainty. And he goes on about talking about the naive empiricist view. So I got another quote here. I can't see it because it's blocked off, so you read that a moment. Basically, what Popper is doing is he allows the theory to be updated, and so allows Einstein's relativity to be updated, and that is thus protective of Einstein's relativity, because Einstein's relativity ends up being updated again and again and again, and so you end up confused as to what Einstein's relativity is after all these updates. And this is another philosopher whose philosophizing has protected Einstein's relativity, because he's philosophized the idea of paradigms. You have in his book, which is a very influential book, The Structure of Scientific Revolutions. He thinks of what Einstein does as a scientific revolution, and so you've had a paradigm shift. You've shifted from how Newton was dealing with things to how Einstein is dealing with things. So you have the Newtonian paradigm and you have the Einsteinian paradigm, and a revolution in physics happened and you swapped from one paradigm to the other. And what it basically means is the paradigm you're in, you just stick to that paradigm and trying to think of things in the context of that paradigm. And this is the book he wrote. So this is how a simplified view of Kern's view of paradigm shift in science. And basically, we are now in the Einsteinian paradigm. And so we've left the Newtonian paradigm. So what it means is that scientists should be trying to fit everything as much as possible to an Einsteinian paradigm. So if you got observation or test of Einstein's relativity, you should, which is not quite agreeing with what you think Einstein's relativity is, you should be trying to interpret that observation still in the context of the Einsteinian paradigm. So he's sort of like, well, what's the problem with that is, well, why not going back and consider the old paradigm, which would be the Newtonian paradigm? And well, you've had the revolution to move over to Einstein, and it's sort of like, well, you don't go backwards. If you want to make a revolution, you're supposed to have something better than Einstein. You don't go back to something older than Einstein, and so it's kind of like stuck physics into this idea of, well, in the Einstein paradigm, you got to stay with it no matter what, unless you've got something better. You don't reconsider the old paradigm. This is the paradigm cycle of Kern. So you've got to have something really radical happen to suddenly get you to move from one paradigm to the other. So that thinking in terms of paradigms, that allows things to be modified, stroke altered, changed within the context of Einsteinian paradigm, and that is very protective of Einstein's relativity. So once again, going back to this diagram, this is the diagram for the scientific method. When you get to this box, the influential philosophers I mentioned, and there are of course others, are allowing a theory to be modified, hence allowing Einstein's relativity to be modified. But that then leads to utter confusion as too many things get changed. And so the scientific method then fills at this box because it's having made too many changes within the context of the Einsteinian paradigm, they haven't kept a proper record of what's been changed. So getting back to the main point to clarify. So this is a person who wrote a paper back in 1967. He was opposed to relativity, thinking it was a major mistake. And this is what you've got now with the sort of change from the Newtonian paradigm to the Einsteinian paradigm. Bernstein Brown was thinking that revolution was a mistake. And he's pointing out the main problem. Einstein, if I quote him, Einstein never wrote a definitive account of his theory. And he then goes on to explain why that is. Einstein never wrote a definitive account of his theory. That allows his theory to be able to have modifications, and those modifications are ad hoc, and it's sort of like just goalpost moving. If you want to replace Einstein's theory with another theory, you have to go through the following steps. Step 1, say precisely what is Einstein's relativity. Step 2, say what Einstein's relativity predicts. Then step 3, propose a new theory that predicts a different answer to Einstein's relativity. Step 4, do an experiment showing that Einstein's relativity fails and your new theory works. But you can't do steps 1 to 2 because, as Bernstein Brown points out, there is no definitive account of what Einstein's relativity is. It's just something that can be modified, changed. Einstein's relativity should never have been accepted. It was accepted, so the scientific method fails and you can't test theories anymore. Finished. Thank you. That's the end of this talk. And I'm not really seeing things so well, so I try to get back out of it. If you try to go back to, I can stop sharing, that's it.
Yes, thank you very much. Excuse me. And
Did you
there's
get
another
all that? Because I've
reason.
lost the sound again. I can't hear again.
Can you hear me? Can you hear me?
Hello.
Can you hear me, Roger? No.
I can't hear you. Can't hear you. Sound's gone.
Well, can you do whatever you did before to get the sound back?
I'll have to come in again. I've lost the sound.
Okay.
I can't. Sorry.
Okay. Well, I'll perhaps do that. Just a little bit of housekeeping. We have quite a number of people who've joined the green room without really telling us. So it's been full. We've had our 10 allocated slots occupied. One person, it gave me a notice, was refused entry because of that. Steps 1 and 2 can be done. I'm not quite sure what that is. But anyway, the slides occupy one slot. So now that they've been taken down, we only have 9, and that person should be able to come in. I'm not sure who it was. We have nine persons at the moment. Any better, Roger? Can you still not hear?
Hello.
You still cannot hear us.
You can hear me, can you?
We can hear you, but you won't be
I
able
can
to
hear
hear
you
our
now.
discussion.
Yeah.
Well, okay. What I might do is I might just spend a moment with your permission.
I can't hear you through StreamYard. I'm going through YouTube.
Can you hear me anyway? Any other way?
Yeah.
Okay. Okay.
I'll try.
This is very messy if our speaker can't hear us, because everybody else, I think, can hear each other. But anyway, I'll just spend a moment, if I may, going briefly through the many comments coming in on social media. Now, most of them, as usual, are just discussions between the members, which they're perfectly at liberty to engage in, but they don't really require us addressing. But if there are any questions there, I'll pinpoint them before going to the members of the green room. So let me see.
Hello.
Yeah, well, here's one question. Is the problem that there have been too many modifications? And I would say, what is too many? Or that the modifications didn't serve a purpose? So, Roger, would you like to address that? Roger, would you like to address that point? This is not working. If Roger can't hear what we're saying,
I've got a delay on this.
Can you hear me at all?
I've got a sound delay on this.
But after
the delay on this,
can you hear what we say? This is a problem we haven't had before, and I fear that when we have people in the green room who come up and maybe say a few things, Roger won't be able to hear what they're saying. Okay, well, yeah, that was one of my questions. What are too many modifications? I mean, it seemed to be an integral part of the scientific process to modify one's hypotheses in the light of experimental results. But, if you keep on doing this, maybe you should go back to your original theory. In particular, I think we should be conscious of introducing what might be considered ad hoc hypotheses to save the theory. So, sort of contravening Occam's razor, introducing all these ad hoc hypotheses. Things like dark matter and dark energy could be considered ad hoc hypotheses, and maybe things like even the neutrino particle. And one other point I had is just can you still can't hear us, I suppose, Roger? No use. So this is not working, unfortunately. I think it's Roger's own system, because everybody else.
So I can't hear you. So
yeah. Well,
I don't know what's going on.
I don't know what to do. So he doesn't hear what I'm saying, and I'm addressing the speaker to a certain extent because some people have almost come to the conclusion that SR can't be falsified, no matter what experiments you provide or experimental results, even results which appear to falsify the theory are sort of twisted around to indicate that they're in support of the theory. It could be said that that's the case in many of the experiments done recently, such as the one on canal rays, for example, which seem to indicate maybe there's a questioning of the thesis of time dilation. Okay, well, let's leave that for the present.
Hi.
Can you hear now?
Can you hear me?
We can hear you perfectly, but you cannot hear us. So how can you respond?
I have a time. I have a time delay on everything.
Yes, but given that time delay, can you hear what I am saying now? No. It's very tedious.
Yeah, but it's a delay. I can hear my voice and it's delayed coming through.
Okay. Well, if it's only a delay, you can address it in 5 minutes' time, if you wish. And I don't have the same concern I have about bringing people from the green room up, because you'll be able to respond to what they're saying. But just give me another few moments to go through these comments. Right. You see, question has said, is Mr. Anderton saying that both relativity and the scientific method have flaws? I don't know if you'd like to address that after the delay time, Roger.
Yes.
You say yes, they both have flaws.
Yeah, yes. Yeah, they both of them got flaws. Yeah.
So how might you suggest modifying the scientific?
Because Einstein's relativity.
But could you suggest how one might modify the scientific method to eradicate those flaws?
I'm going to write my comments because it's no good talking. I'm just getting time delay and it's completely confusing me.
You're going to type your comment in the private chat. This is a pity now. Anyway, I'll continue. I'll continue just going through these very briefly. I have to speed up because otherwise we'll be here all day looking at them. There are probably hundreds of comments in here. And by the way, if anybody in the social media really wants a question answered or a point disputed, just put specific question for Roger. Because at the moment, I may not be able to eliminate those questions which are specific rather than just discussion. People talking about plagiarism and Einstein and all that. Lunds, who's that? Yeah, somebody said I never heard of Lunds. I think he means Lorenz. Henrik Antoon Lorenz. Cochrane. Bum. One comment has been, why are we spending so much time on Einstein? Probably not only today, but all over the months and years that we have. I responded that perhaps it's a response to the general world and the mainstream science concentrating on Einstein. It's not something originated by us. Lorentz and based on Maxwell's equations. So on. Okay. Now, as I say, there are a number of people in the green room. People I'd like to introduce. You're all very welcome. I can see most of you. So if you have anything urgent, you might like to put up your hand, and I'll bring you up immediately. But even if you don't, okay, you're putting your comments in the private chat, are you? Okay, let's see what you say. Okay, I've missed this now. Okay, Thank you for signaling that. Yeah, thank you. Einstein's relativity is flawed, so gets modified, and that messes up scientific method. Laribi Bertine, I hope I'm pronouncing his name correctly. Yes, they say in this sense. Einstein never properly clarified how connected Lorentz. We can hear Roger, so he does not need to type chat comments. Yeah, James Keane has said that, Roger. We can hear you. You can't hear us. So you don't need to type it. You could just say, may I speak about something that you've spoken about 3 minutes ago, and we'll listen to that. Okay, so that's a good point. There's a time delay. I talk, and then 5 seconds later, I hear myself. Yeah, well, that's a problem as well. So, now, you haven't been very forthcoming, new gentlemen, I call you, because you haven't been in the green room, in my recollection. So, Vladimir Netchelio, I hope I'm not making too much of a mess of your name. You're very welcome, Vladimir.
Thank you so much.
So, would you like to say a couple of words about yourself and your interest in this subject, and then maybe pose some discussion for Roger?
Yes, I would like to say a few words about this representation. First of all, do we really need relativity at all? Because we live with you in absolute frame of reference, we can measure all our bodies, suns, earth, moving against microwave background radiation. Then it's a wasted time to talk about relativity. It's some kind of mathematical exercises, what to do, how to do, and so on and so on. We should take into account that we live in an absolute frame of reference. That's why all this special relativity, general relativity, they are not valid in this situation. The second very important point, even existence of microwave background radiation means we live in some kind of the medium. I can talk about the mediums maybe in the future presentations. And if we live in a presentation, then there is no vacuum, there is no speed of light in vacuum, and all this stuff. It's a basis for general and special relativity. Vacuum, speed of light, and so on and so on. Speed of light depends on the parameters of the medium we live in. That's why, as for me, we should move out of paradigm general relativity and to do something about it, to give a new paradigm. It's exactly what I'm trying to do for 22 years.
So I don't know if Roger got some of that, albeit delayed. That you're talking about, having a frame of reference, which is maybe the general cosmic microwave background radiation.
Not only there is intergalactic plasma, there is far infrared background radiation, there is a gamma radiation, a lot of stuff we have inside of the medium.
Do you conceive of an ether? This medium being a sort of an ether with magnetic and electric properties.
Magnetic and electric properties, it's a properties of a normal, only ordinary matter. And we have only 7% of this matter. All the rest matter is something we don't know, it seems to us. It's exactly what is my point. We must build our theory based on dark matter, because dark matter is 93% of our medium, of our world. How we can build something based on a 7% and we miss our 93% of the matter?
Yeah, that's an interesting proposition. Although I think a number of us would consider that there's no real evidence, that 93% of matter is dark to us. That's really been maybe a bit of an adjustment to try to save the existing theories. We're getting.
No, it's not adjustment, because you can calculate critical energy density of our medium, and you can see that we have a normal material only matter only 7%, 93% it is something else. It's easy. And what is important, critical energy density, you can calculate based on a Hubble equations, on a Hubble law. That's it. You don't need general relativity. You don't need anything. General relativity, it's interesting. When we have special relativity, we canceled Eiffel. When we started to work with general relativity, it's not only Minkowski spacetime. We introduced some absolute medium, absolute liquid. I don't know what is this, because if you will take a look on a Friedman equations, there are some pressure, there are some, energy density, mass density, and all this stuff. Do we have in general relativity the medium Eiffel or no? This is a very first question.
So when you mentioned the Hubble equation there, do you conceive of a Hubble law as being merely a relationship between redshift and distance of objects, or do you conceive of it as related to the velocity of recession of those objects? In other words, do you accept the expanding universe hypothesis?
Yes, expanding universe. Yes, of course. There is the beginning of our world, and there is expansion of our world. Yes.
Okay, yeah. So I was sort of gleaning that from what you were saying. That
Yeah. It's a very good question. Please ask me as much as you
I'd say
can,
you're sort of
because
halfway between the mainstream and many of us here. In that we agree with a lot of what you've said, but I think you're not quite as dissident as many of us who would actually reject that the universe had a beginning. They'd reject the Big Bang. They'd reject the expansion of the universe, and they'd reject dark matter. But anyway, so where are you publishing, by the way, Vladimir? You said you're working on
a journal of high energy physics, gravitation, and cosmology. It's some journal, very good for me, because they accepted my papers, and I published already over 35 papers already in this journal for 8 years of my publishing. That's why.
I may just pry a little. Are you retired, or are you a working academic?
Right now I retired. I'm freelancer for 3.5 years because, of pandemic, it was some business problems, and immediately from such guys like myself, they gave me lay off, and that's it. By the way, I live in California. That's why for me...
that was my next question, so you've answered it. Okay. Well, thank you very much. We may bring you back because, we certainly have over an hour to spare, and I saw some new names. We have some other new names, and I'll bring them up. If you have anything,
let me clarify only one question. About the Big Bang. I'm against Big Bang because it's crazy. For physicists, any singularity, any infinity, it's wrong, absolutely wrong. That's why I have the beginning, but totally different beginning. There is a fluctuation of very small some ball, 4-dimensional ball, and then we have a continuous creation of matter in our world. That's why there are no infinities, there are no connection to the existing Big Bang model. I'm always I'm always against this theory, because it's not scientific, it's not physical even, to start with singularity and then to suppose that all the world inside of this point. I'm very sorry. It's crazy. Yeah. It's exactly
that's the mathematicians. I mean, it's the 11th commandment that, thou shalt not have a singularity. Thou shalt not divide by zero.
Yes, but what is important, as for me, for the last 100 years, instead of physicists, we have mathematicians only. They're solving some mathematical problems in general relativity, special relativity, twin paradox, and all this stuff, instead of physicists. Where are the new ideas? How to explain what we can observe right now, especially with this GWST right now? There is no way to explain in existing theory all these results. And on the contrary, in my model, I can explain all these, features what we have right now.
Well, the last thing, just for the present, I'd mention to you, Vladimir, and to the others, the other new people, is we're always looking for Saturday speakers. I was going to say Saturday afternoon, but for you it's Saturday morning speakers, and we're sort of running out of speakers. Actually, we have speakers until the end of November. So in other words, another couple of months. But if you would be able to give us a talk on a Saturday, maybe in December or January, if you just drop me a line, I'd be very happy to look at it and maybe come back to you.
Yes, of course. I would like to make a presentation. Nick, he invited me to your talks, to your presentations, and he invited to make a talk about my model and the main points of my model. Yes,
sorry, who invited you?
Nick.
Oh, Nick, yeah. I'll be talking to. We'll have Nick up in a moment. Okay, Nick is always great for bringing new people in.
Yes, I have a very good talk, letters with him back and forth. And after all these our conversations, he told me, Vladimir, maybe you will make a presentation at our meeting. I thought, okay, I'm ready. Not yet, because I would like to have some time. But December, it's very good time for me to join you and to make a presentation of my model, or maybe a part of the model, because I developed all the model. It's a totally different view of the world, what I would like to present to you guys.
Okay, so my email is Ian Cowan, IANCOWANDR @gmail.com. If you want to send me IanCowanDR @gmail.com, if you want to send me just a brief title and maybe one or two lines, I could come back and say what dates are available. So I'll bring it down for the moment, Vladimir, and if you want to come back, just wave your hand. Thanks very much for coming.
Thank you so much for asking these questions, because that's why I would like to be part of you, because I am in your community, not in a Big Bang model community. That's why.
And we need to expand and have people of different views, because dare I say it, I mean, I've been around for some time here, not as long as some others, but I basically know very much what Roger thinks, or what Nick thinks, or what James thinks, or what Denny thinks on certain issues. So I if we have it wider, it can only be for the better. It can widen our discussion. So thanks again.
Yes.
Sorry, I've just brought you down. Now, I'll just see. We also have Stephen Gift, who's muted and has no camera at the moment. Can you hear us, Stephen?
Yes, I can. I've switched on the camera. Good morning to everyone. Morning.
Good morning to you. Good afternoon from here.
Okay.
So Stephen, again, I mean, did Nick invite you, or you're very welcome? It's just we haven't had you before in the green room, I think.
Well, I see the invitation it comes into my email. I have attended NPA activities in the past, and I think Nick or somebody would circulate the invitation. So normally on a Saturday, I'm quite busy in the morning, so I hardly am able to attend. But I made some time this morning just because I saw Roger was coming up with something, and I decided to try to come in and hear what he had to say. I engage with these guys through a chat group that we have, Nick and Roger and a number of others. So I have a great interest, of course, in many of these topics. So here I am this morning.
So would you like to say a few words, Stephen, just about your own experience and work, and maybe your brief response to Roger's presentation today? Sure. And if you have any questions, even, we can deal with them.
Sure. All right. It's no problem, but let me just say that my first name is Stefan.
I beg your pardon.
Yes, that's okay. That's okay. All right. So, well, I'm an electrical engineer, Ian. I am a professor of electrical engineering at the University of the West Indies in Trinidad and Tobago. Well, it has 3 campuses: Trinidad and Tobago, Barbados, and Jamaica, and it's expanding. In fact, there's 2 other campuses, but I won't go into too much into that. I have had an interest in special relativity for quite some time, and it's over that period. So this is why I've attended some of the NPAs. That's Natural Philosophy Alliance. I think that's the NPA group that used to be. I don't know if it's still around. But let me say, Ian, that I have myself determined that, whereas many of your special relativity, which is the focus I have had, is invalid, although I do not, the comment you saw where I said that I don't agree with Roger, that's his steps 1 and 2, where he said define the theory and make predictions. I disagree with him, and I've told him that a number of times, that special relativity is sufficiently well defined. And Roger tends to focus on what Einstein said. You know, Einstein said it 100 years ago. What happens is theories develop over time. And what we have today, look in a current book, you know, French's book or Resnick or Rindler or some of the later texts. And in there, you will see a sufficiently well-defined theory that we can focus on. Now, I agree with him that they have been trying, they shift from time to time in attempts to save it when things pop up and so on, but we must not allow ourselves to be distracted by that. We must focus on those things that are well defined. So the theory has 2 main postulates, the relativity postulate and the postulate of the principle of light speed constancy. And it makes some very clear predictions, one of which is the speed of light is constant in all inertial frames. If you take the Lorentz transformations, you can actually derive a light speed prediction from them. I've done it. And that is a clear prediction which can be tested. And in fact, there are a number of other predictions. Now, the speaker that you just had is Vladimir is his name. I don't agree with him when he says that relativity, special or general, are unimportant. The fact of the matter is the whole world of science practices with these 2 theories. And in fact, special relativity has made a number of verified predictions. So you have relativistic beaming, where a fast-moving source of light tends to narrow its focus forward. That has been tested and verified. Then you have transverse Doppler. You know, that is not part of classical mechanics. And then you have this wonderful discovery about the Thomson precession. What happens when an electron orbits an atom? So these are clear predictions that have been tested and verified. So to say that the theory has no relevance is really, that is not correct to say that. However, so I'm saying the theory makes some very clear predictions which can be tested. So I mentioned 3 there that have been verified, but some of them have failed. So the light speed prediction, do you know, Ian, do your colleagues know that although physicists go around talking about light speed constancy as though it has been verified, if you look in the book by Zhang, published in 1997, he shows that one-way light speed constancy has not been verified. So that it's a fact of life, although the physicists don't like, the relativists don't like to hear that. The fact is it has not been verified. And I have used the GPS in papers I have published, not in mainstream, you know, they don't tolerate these publications in mainstream journals, but I've published in physics essays and a couple others that are peer-reviewed, but would accommodate, you know, these dissident ideas. And I have shown that the GPS shows that this light travels faster west than east. That's a simple fact of life that is easy to demonstrate.
Yeah, that's effectively the Sagnac effect.
Well, I don't want, though, you see, Ian, when you say that, you are now being, you are being influenced by the relativists. Don't call it the Sagnac effect. Let me put it this way. If you take 2 fixed points on the surface of the earth, east-west points, and you send a light beam from west to east and one from east to west between those fixed points, you will find that the light travels faster west than east. Whatever the reason, I don't want to get into the reason, because the prediction is those light speeds are supposed to be constant the same. But I'm contending that if you actually measure, and you know what, we have the means to measure it. The synchronized clocks of the GPS are available to take those measurements, and they do. But what they call it is the Sagna correction, and suggest that there is this problem going on there, that they have to correct it with that. But light is really traveling at light speed c. So
well, they do that because it's the same effect as electromagnetic radiation going around a spinning disk in opposite direction, which was first introduced by the experiments of Sagnac in 1913. So that's why it's not really a relativistic thing. It's perhaps anti-relativistic, I would maintain.
Well, correct. But you see, we must put it frame it in a way to show what it is. It is a difference in light speed in the two directions, Ian.
Well, that's great, Stefan, yeah.
And that is really what we should put it forward as. So that's a direct conflict with the constant light speed prediction of special relativity. So just to summarize then, I am saying that the theory is well enough defined. It makes some clear predictions which can be tested. And several of them, I have gone through the process and they have come up. One of them is the light speed constancy. And there are a couple others that we could go into later on. And then I will close with this, Ian. I have been searching for some time for a replacement set of transformations because I believe transformations are necessary. And I have unearthed what I call the celery transformations. You might know him, Franco Celery. I think he's presented on this forum in the past. He has put forward a set of transformations which I believe to be correct. And I've spent a long time testing them. And I have found no flaw. Hear me? I have found no flaw in those transformations to date. And I have put them through a whole series of tests. And the transformations have passed all of them. So I am advancing the celery transformations. He called them inertial transformations, but I named them after him because he's done the most work with them and provided them with a solid foundation. I believe that they are the correct space-time transformations that should replace the celery, the Lorentz transformations of special relativity. So those are my comments, Ian. Thank you for allowing me to make
Not at all. They're most welcome, Stefan. Thank you very much indeed. And needless to say, the same invitation is extended to you as extended to Vladimir, that we'd actually very much like to hear you give a presentation one Saturday. And if you have a specific topic, such as what you were just talking about, and you might want to contact me and maybe just give me a description, a line or two of description, we can put you down for some Saturday.
Okay, I'll give it consideration. Thank you.
Thank you very much, Stefan.
Okay.
Thank you. Okay, now we haven't exhausted the new people. There's Alistair Beale, and I hope I haven't pronounced your names incorrectly, Alistair. Can you? No, we can't hear you. You're probably muted. It doesn't give me a signal to say you're muted here, but we couldn't hear you, or I couldn't hear you anyway. Can you make sure your mic is on? No, it's not. It's not coming through. Oh, so maybe you can just see what you can do. I'll just bring it down for the second. Anyway, as I say, if you have any specific point you want to raise about today's lecture, just put a note in the comments there, the chat, and the same invitation as I extended to Vladimir and Stefan is extended to you. And if you get your problem, your sound problem solved, just put up your hand like that, and I'll bring you back. So thanks very much for coming today. Now we have another person, Laribi Bedruddin, and I apologize if I've mispronounced any of the names there. Can you hear us, Laribi? Can you hear me? No, you're mute. You're mute. It says you're mute, actually. So you'll have to unmute yourself. Unmute your mic. No. Okay. You're mute. That's why we can't hear you. Yeah. You have to unmute the mic yourself. I can't do that. But anyway, if you have any comments on Roger's presentation today, just pop them in there and we can deal with them. And again, the same invitation as I extended to our other new people is extended to you. And if you get the problem solved, just wave your hand and I'll bring you back. You're very welcome today anyway. Sorry we couldn't hear you. There have been a number of technical problems today. Now, I better... Nick, you're the instigator, or we really are indebted to you, but I think you've brought a number of new participants in. I call them new because I personally haven't met them before. You're muted, Nick. You're muted.
Hello.
Hello.
Yes. Well,
so,
today is my birthday, so I decided.
Happy birthday.
Thank you. So I decided to attend in my birthday suit, and since I have an artificial intelligence operating system, it has censored my camera, so it has better taste than I do. Anyways, welcome to Stefan and Vladimir and Alistair. Good to see you here. I don't want to shock Stefan too much, but I agree with everything he was saying, including the Sagnac effect. Of course, at the very end, when he was talking about the Solari transformations, he knows that I'm not quite so enthusiastic about them. But Franco Solari was a very great professor. I want to thank Roger. I thought it was most interesting to look at special relativity through the lens of the scientific method. And that was a catalyst to all sorts of other peripheral ideas. Let me just expand on, in agreement with Roger, about something. I have debated relativist professors for 60 years, so I greatly appreciate his pictorial about a moving goalpost. I would just suggest two things. A number of times I used the Socratic method with relativistic professors where their answers led them to a contradiction. But then rather than moving the goalposts, I would say that they had two different goalposts. And if you scored a goal in one, they'd say, oops, wrong goalpost. And they totally changed the interpretation of special relativity to be something quite different than what we've been talking about. So that was an interesting discussion by Roger. Also in support of Roger, a number of academics, well, I guess virtually all relativists, have admitted that they could not define a seamless union of special relativity and general relativity. So there's a number of indication that there's some confusion going on and some discord between the two theories, even though a lot of special relativity problems were added to the original core of general relativity, to their equations for gravity. Another problem, of course, with relativity is that once one has a very strong belief system about something, then it's their abilities and their aptitude for math and physics and their abilities for critical thinking is hampered in that area. And I think that applies to all of us, not only academia, but a lot of us in the dissident community. Once we have worked decades and come up with a theory, then it's very difficult to see it in the light of the scientific method. Also in support of Roger, Professor Hasok Chang, then of Harvard, did an extensive review and analysis of the twin paradox debate. And although the relativists claimed victory, his independent view, he was not a critic of special relativity, his objective view was that they had never addressed the issues that Dingle had brought up. Quite interesting, I found. The one good point, Roger was talking about making incremental changes to special relativity, sometimes even more than incremental changes. But the problem with special relativity was that there was a fundamental flaw, a foundational flaw. So basically, you can't get away from that unless you say goodbye special relativity and start with something else. Too bad I have one of the same little icons of Einstein that Roger just waved at me. I could wave back. Get away from that unless you say goodbye special relativity and start with something. Oh, Roger, mute yourself. Too bad I have one.
I know I've had to remove him because he has a delay in his line, so he's just
I know.
getting
I was
what
wondering.
you're saying after a few minutes, Nick.
Yeah. So, if you start with special relativity, you're starting on a bad foundation, and all of these incremental changes have just made a taller tower built on a invalid foundation. And soon, right now, it's like the Leaning Tower of Pizza, but soon it's going to fall over. Anyway, my one disagreement with Roger was he said that Minkowski added in a preferred frame. Well, having looked at that in depth for decades, in the context of the twin paradox, what happens is that when you draw a Minkowski diagram, you're drawing it from the non-traveling guy. So you imply that that's the preferred frame. But if you draw the Minkowski diagram for the traveling twin when he's in a steady velocity point of view, then you get a contradictory thing. So basically, the Minkowski theory is quite true to relativity, and it says that every frame simulates being the single preferred frame. And when you have that as a foundation, it's pretty simple to see that that's not a very good foundation for physics.
So may I ask you one thing, Nick,
yes.
on that? Stefan mentioned a few sort of experiments which would appear to be consonant with special relativity, like the Thomas precession and the Doppler effect, which is transverse and all that sort of thing. Would you maintain that those experiments could be established to be in line with a preferred frame through the Lorentz-Seether theory as well?
Well, that's another major topic that I think we need to delay.
Right. So it's something we may address later.
Yeah.
Because it's interesting.
But I do agree with Stefan that special relativity has really gotten now a de facto target to shoot at. And while they may try in debates with dissidents to shift their definition of relativity, either explicitly or implicitly, more likely implicitly, there is a de facto target out there that's pretty well defined.
Okay. Well, thank you very much for all those comments. Very incisive as usual. And I do regret that the comments that are being made now, particularly through the green room, are not capable of really being addressed by our speaker today because of the technical hitches we have. But anyway, they're recorded, and so I'll bring it down for the moment, Nick. And if you want to come back, you won't be able to signal because of your lack of audio, but video rather. But if you send a signal in or a statement in, we can do that. So thanks very much, Nick. Actually, I might just mention one thing before you go. I suppose I'm doing a bit of business in public now, but I know you yourself were looking at maybe the possibility of hosting some of these sessions once you were set up with administrative rights to StreamYard. Now, I haven't had an opportunity.
No. That's not. I'm not ready to host at this time.
Okay.
Yeah.
Well, that's fine, because what I was going to say, that hasn't been established. But the good news is basically that Roger is in a position once he gets over his technical problems, hopefully. So he's in the process of speaking to David about getting set up. And that also applies to Franklin, who's joined us, and I might speak to in a moment.
Oh, good.
Yeah,
maybe even Harry. Maybe even Harry.
Maybe even Harry, although I think Harry said he couldn't guarantee his availability.
Dear.
So thanks very much, Nick, for the moment. Now, so let me see. Those are the new. I call them new people, but I'm sure that they've been around as long as I have. Denny, Dennis P. Allen Jr. I'm just checking really whether you have any response to Roger's points that he raised today, and any suggestion as to how we might go further on some of the other points raised. You're muted, actually. No, that's all right. Yeah, got you there. Yeah.
Well, I think Roger is right about the fact that there's so many different versions of special relativity. But the problem isn't the scientific method, it's a lack of honesty. The scientific method can't really work if people are dishonest.
Okay, well, that's an interesting position, which maybe Roger will come back to at a later stage, because I'm not sure that might be a corollary of what he's saying, that they're not totally honest and they just want to believe something and that they're changing the goalposts all the time. But I think his point is very fundamental, that he's saying that this has given us an example of how the scientific method is failing, presumably because we're not able to deduce the correct results because of goalpost changing, as he calls it.
I think that most scientists who are really into that know that there are problems with special relativity, but the political situation is just too politically incorrect to try to deal with them instead of just necking on this and that, to actually overthrow the thing and go to, say, Salerni's point of view. It's just, your whole career, even though you have tenure, could go right down the drain if you're not careful. There was a man by the name of Thomas Merton, who graduated from Yale, and went into, became a Trappist monk in Gethsemane, Kentucky monastery. And he pointed out that in the old days, people used to wear body armor so that the person standing next to them couldn't turn around and stab them in the back. The body armor would protect them. But now, the situation
is that better?
Can you hear me?
Yeah, we can hear. Sorry to interrupt you, Denny, but Roger has come back on a laptop and it's all right now, so you can hear what they're saying. Go ahead.
Okay, I'm back now.
Shall I continue, or?
Yeah, carry on. Cheers.
Nowadays, people are afraid not that someone next to him is going to turn around and stab him in the back, but they'll turn around and stab themselves in the back. And this is, of course, she's referring to cancel culture and so on.
Oh, right.
One wrong move and your career in academia is gone. You know, you can go out. They won't arrest you, but they will send you out to McDonald's so you can flip hamburgers for a living, rather than be a professor at the university.
Yeah. Okay. Well. Thanks very much for that, Denny. If you want to come back, just signal. Roger, is there any brief response you want to make to all those points? You know, we've had points from Alistair. You know, he would appear to counter a number of the commonly accepted views, and yet he seems to accept the beginning of the universe and so on. And then Stefan has made some very interesting points about some sort of small scale. I'm getting a delay now. I'm hearing my own voice coming in.
Oh dear.
Maybe you can get rid of that. The feedback. Can you get rid of the feedback?
Me?
Then you can't hear it. You'd have to put headphones on. See, I'm hearing my own voice back to me now.
Okay, hold on. I get headphones.
Yeah. Okay. And you know, Stefan has made a number of points about these, what I would call, well, microscopic or mini, bad word. It's just not universal, not concerned with the cosmos, but these sort of experiments that would seem to substantiate special relativity and so on. Unfortunately, we couldn't get. Yeah, Alistair's coming back. Yeah, okay. Alistair, you're back. What? Can we hear you now?
I've put it on a different computer. I've not got a lot to say. It's more a flyer for what you might get in future. I've got a new paper that's currently in assessment for possible publication, which, depending on how you look at it, might some people might say it caused a lot of trouble. Some people might say it'll save everybody a lot of trouble. What I've done is I've gone back to Einstein's 1905 paper and gone through the logic and the mathematics of analysis in its own terms and found a string of serious mistakes, which lead to the conclusion that his analysis doesn't predict the Lorentz equations. In fact, it's got two possible solutions. His analysis doesn't predict that moving clocks will run slow. In fact, if they do, that undermines his whole analysis, and it doesn't predict the twins paradox. I just thought I'd give you a flyer. The detail of that's got to wait for another day, just to give you a bit of a flyer that basically, having gone into considerable detail, Einstein's 1905 paper collapses once you actually follow his analysis very carefully through as it is. And it doesn't change what happens out in the world, but it changes the theory you apply to explain them.
Okay. Well, that other day that you referred to might be, if you do take up our invitation to address us, and maybe let me know how you might. You're obviously from Scotland the Brave.
Well, I'm in Yorkshire now.
You're in Yorkshire at the moment, yeah. Just to check the little Scots accent there.
Yeah.
Okay. Sorry to pry again, but you're probably retired, are you? And you're doing work.
I'm more or less retired. I'm a civil and structural engineer.
Okay.
I've been working on this for quite a long time, and eventually got to think I started by trying to understand what Einstein's explanation for things. I've ended up, I think, comprehensively disproving his analysis in his paper. As I say, it doesn't change anything that happens out in the big wide world, but the explanation Einstein offered for it in 1905 collapses.
Okay, so this is where there might be a sort of a coming together with some of Nick's ideas, where, you can put atomic clocks on spacecraft or GPS satellites, and you can find that they go slow. But it doesn't actually mean, in fact, it doesn't mean, we might say, that there's any time dilation at all. Okay. So thank you very much, Alistair, for that. I think, yeah, Stephen wants to come back. So I just, sorry, I've made the same as Stefan. Stefan.
That's
You
okay.
want to come back, Stefan?
Yeah. Ian, a quick comment. Something you said and what the gentleman who just spoke said regarding your comment. I just want to make it clear that I certainly believe that special relativity is wrong. I mentioned those particular predictions that were correct just to point out, in response to Roger's comments, that some clear positive predictions have been made by the theory. So the theory has been successful to some extent. But I'm saying it also has made predictions which are wrong, which allow it to be tested, contrary to what Roger is saying, that it can't be tested. It makes some clear predictions which are wrong. I mentioned it predicts that light speed is constant, and that can be shown to be wrong. It predicts symmetrical clock retardation, which has been shown to be wrong. It predicts relative simultaneity. Well, that one, I've done some work on that, and we can use the GPS to disprove that as well. But coming to the comments that were just made, I want to argue that the reason we have such difficulty as dissidents, it's unfair, but that's just the way the world is we are expected that if we want to show that this accepted theory is wrong, at the very least, we must advance a replacement. And if you look at most of the critics, Dingle didn't have a replacement. McCausland didn't have one. Waldron had the emission theory, but that fails. It doesn't pass the test. So the problem, I believe, quite apart from the fact that if you want to disprove an accepted paradigm, there are so many careers depending on this and all of that. There's a real mountain to climb. Well, one needs to have a viable replacement. I didn't make the rules. That's an unfair rule, but it's there. If you want to have a chance, you have to have a replacement. This is why I have moved beyond merely being critical of special relativity to trying to identify a correct replacement. What is, if the Lorentz transformations are wrong, then what are the correct transformations? It can't be the Galilean transformations, because they are inadequate. They don't predict some of the so-called relativistic effects. They operate at low speeds, but they fail at high speeds. So we need a viable replacement. And that is why I argued, and I know Nick disagrees with me, I argue that the celery transformations fit that bill very well. And I've been spending much time taking them through the paces, because if I'm going to offer that as a replacement, as celery has tried to do, we have to go through the full gamut of physical phenomena that are addressed in all those special relativity books and show that these new transformations can address them all successfully. There must not be a single failure. And I will close with this, Ian. Okay. What I have found is that the celery transformations, there are no paradoxes. Gone are all paradoxes, just to start with. So all this stuff about twins paradox and the pole in the ball paradox and all of that stuff, it's gone from the celery transformations. Thank you.
Well, thank you very much, Stefan. Just without imposing too much my own ideas on it, I just noted a question here. I have extreme doubts about the Lorentz transformation itself. Well, I have doubts about applying these transformations generally to I'll just get rid of that. Generally to dynamics. You see, to me, in a nutshell, we can come back to this at a later stage, maybe, but in a nutshell, I view things like Lorentz transformations applying to electromagnetic radiation as a sort of like a quick fix. They're not ultimately true. And I could say the same about Solari transformations, although I'd have to study it in more detail. It would be a bit, pompous of me to start making that point now. But
Yeah.
To me, if you take into account, and this has been talked elsewhere as well, if you take into account the diffusive effect of electromagnetic radiation going through a medium, in other words, the same as we do in fluid dynamics, and you take a total derivative, which is not just merely the partial derivative, you take a total derivative.
Yeah.
Well, then you find that the wave equation and the Maxwell equations are basically apply in all frames of reference. Where one frame of reference is moving at a velocity which needn't actually be constant relative to another body. So if you don't bring that in, well, then you say what transformations would I need if I just put a partial derivative in instead of the total derivative, which is like including the v dot nabla term. Well, then I would need to introduce this gamma factor, which is the Lorentz transformation. Now, so that's a quick fix to me. And then I have problems introducing that into dynamics, because my own working hypothesis at the moment is that and you probably disagree with this, Stefan, but is that the Galilean transformations are quite adequate. They're quite true for ordinary dynamics. So this is something I think we could come back to, and we could have a talk about that in a full 2 hours session on it.
Yes, and Ian, just to respond quickly,
yeah,
the Thomas precession in an atom when an electron orbits in the atom, I am not aware of any other explanation for that phenomenon. The fact that Larmor precession is reduced by a half as a result of what happens with the Lorentz transformation. I am not aware of any other explanation for that phenomenon. So one has to say that is an entirely relativistic prediction, if you like. Nothing else could explain it. Happily, I am pleased to say the Solari transformations also predict that phenomenon. I shared that with my chat group recently. So I'm saying there are relativistic phenomena, which, take for instance, clock retardation. I am not aware that anything else accounts for that in terms of predicting it. It is an entirely relativistic phenomenon. So Galilean transformations can't account for that. And therefore, we have to move beyond the Galilean transformations. Effective though they are at low speeds, at these high speeds, we need something more. Now, I'm not saying that all phenomena need transformations to explain them, which is your point about some of what is happening in electromagnetic theory. I am not contending that at all, but I am certainly saying there is a whole range of phenomena where you need transformations to account for them. And I am arguing that the Lorentz transformations are wrong, but that the Solari transformations are the one to replace them.
Okay, well, that's something I think we need to come back to at a later stage. And I wouldn't dispute with that. I'd say you probably do get the right answers. It's a bit philosophical to say whether these are sort of like prompting the explanation or whether they're, to use my slightly emotive terms, just a quick fix. They just give you the right answers. We'll come back to that. Thank you very much.
Sure. Thanks a lot. Okay.
Thank you, Stefan. So let me see now where we are. We have 20 minutes left, and I do need a few minutes to summarize.
Try me again.
Roger probably wants to come back now that he's we can hear him.
Can you hear me?
Ahead, Roger.
Great. Okay. So sadly, I've missed most of everything. I think it's when there's too many people in the green room, it's maybe there's too much memories being used, and my computer wasn't able to handle it.
Could have been.
Yeah, something like that. It's technical. The computers seem to be, you've got to have really recent ones to keep up to date with things. It's sort of like a problem that wasn't happening before.
Although I don't know why it wasn't affecting others. Like, it just said to me, you've exceeded the number in the green room.
Yeah.
But it didn't cut anything off. However,
it's my computer wasn't able to handle it, so I don't know why. So it was working the other time, wasn't it? This time it's suddenly the difference seems to be there's more people, and so it's been pretty annoying to me to this talk that I've not been able to follow what people have been saying. I got a bit of what Stefan was saying. So he doesn't agree that Einstein's relativity has not been tested, well, something like that. But sort of like he comes out with things like saying that constancy of the speed of light has been disproven. But then you get people who start reading Einstein's papers, and Einstein did consider variable speeds of light. So you've got people like Axing saying that this really should be dealing with a variable speed of light. So if you've done an experiment and you said, right, the speed of light is not constant, it's variable, then you still end up with saying, well, Einstein was right when he was talking about a variable light speed. So you're still ending up with Einstein's relativity being ambiguous, and then you're swapping over from thinking of the way they've been thinking about it as constant light speed to then it being a theory of variable light speed. So you're still within what is effectively the Einsteinian paradigm. And if you're still staying within the Einsteinian paradigm, the mainstream is just going to keep saying that it's Einstein's relativity, no matter how many changes are being made to it. So with Stephen, when he was saying about the Sorelli transformations, if the mainstream start deciding, well, those are good, that is good bit of mathematics, and they decide that is good, then they just decide, well, that's really what Einstein meant. And so they just adopt that and keep it still within the Einsteinian paradigm and say it's Einstein's relativity. They're not thinking in terms of moving out of the Einsteinian paradigm. And when they still stay within the Einsteinian paradigm, they're just going to keep calling it Einstein's relativity. So this thing about
how might you address Stefan's points? I mean, if the theory is in such a mess, indeed, that it seems to, well, he says uniquely, he says uniquely predict a number of effects like the Larmor precession and Thomas precession and these things, the Doppler, the transverse Doppler effect. How would you address that sort of thing, Roger?
Well, is that in the context of what they believe about Einstein's relativity now? Because they've managed to fit it in with those sort of experiments. Well, that's what they say. They say the experiments agree with Einstein, and then it's sort of like, well, what version of Einstein are you making going by what Einstein originally says about that, or are you making an amendment to it and still calling it Einstein's relativity? It's where the scientific method fails if you're allowing the theory to be amended all the time, and you're not saying precisely what you've changed. It is a mess, basically. And when you read these scientific papers, the person who's written the scientific paper for an experiment is not teaching you Einstein's relativity per se. Normally, they're not telling you what Einstein's relativity is. They're assuming you know what Einstein's relativity is, and they're giving you the data from the experiment, and then they're saying, yeah, this agrees with Einstein's relativity, but you don't know what version they're talking about because there's been changes made to it. And so it's just a mess. And when you go to the education system, I mean, I was taught it decades ago, Einstein's relativity, and they told me about relativistic mass. They said that's an important thing. And you go to Feynman's lectures on relativity, it says you don't have to bother about anything else about relativity. All you have to know about is relativistic mass. But then a few months ago, I went to a course at Oxford, which is now teaching relativity, and they've discarded that idea. That they're not teaching that anymore. They're saying relativistic mass is wrong. So they've made another change. And so what text is telling you that there's been this change? They're teaching one thing decades ago, and they're teaching something else decades later, and they're still calling it Einstein's relativity, but they've made a change to it, and they're not explaining why they've made the change to it. So the student, if you're a naive student, you go in there and you're listening to these lectures, you're thinking what's being taught is what being taught decades ago, but no, it's not what being taught decades ago. They're teaching something different now to what they were teaching decades ago, and they're not explaining why they're doing that. It's all just a mess.
This is unique, Roger? I mean, you've
So,
made very fundamental points about the whole thing
Yeah.
being a mess and reinterpretation so on.
Yeah.
But is this unique? Do you think this has ever been done with other theories? I mean, has it been done with Newton, or has it been done with Galileo?
Well, with Newton, at least you got his book. Newton's got his book, the Principia. If you sort of like disagree with Newton's theory, you've got something written in stone, pretty much, as to what the theory is, what Newton thought the theory is. But if you go to Einstein, you read through him over the years as what he's saying. He seems to be changing his mind all the time. In 1905, if you read his paper, he seems to be saying, "Oh, there's no ether," but that's an interpretation. That is an interpretation of what he's saying. You think, well, he's saying there's no ether. And then 1920, he gives a talk which seems to say there is an ether. And that's another interpretation. So he seems to be changing his mind all the time. You've got all these papers from Einstein, and they're not saying the same thing. The theory is just changing. It's not a theory set in stone like you had in Newton. It's a theory.
It's almost unique.
Where Einstein. It's a theory where Einstein keeps changing his mind. It's not a fully formed theory in 1905. It's sort of like something which is going to be amended. It's not the same thing. And if you let the scientific method into that, well, you haven't got a definitive theory, as Bernstein Brown pointed out in 1967. You haven't got a theory which is definitive. It's going to keep changing. And so, well, what are you testing? You've tested Einstein's relativity. You done an experiment, and you think, oh, it doesn't quite fit with Einstein's relativity. Then you change what you think Einstein's relativity is, and then you say, yeah, it fits Einstein's relativity. But you're not letting people know explicitly what you've changed.
Okay, well, maybe with your permission, prior to giving you an opportunity of summarizing today's proceedings, Roger, I'll just try briefly to bring in two other people in the green room. So, Jim, if you could be very brief, but I know you normally have some insightful comments to make, and if you could make them very briefly, just so we could either deal with them now or include them in Roger's summary, that would be appreciated.
Well, thanks to Roger, and also to Nick for bringing in new blood, new possible speakers, for a greater diversity of opinion and points of view to be expressed here. It can only help this forum. And lastly, congratulations to Ian, who has shown himself to be extremely adept in making the best of a situation in today's session where we've had a number of technical difficulties. So, Ian, you're quite a moderator. Fantastic.
You're too kind. Thank you very much, Jim, and thank you for your comments as ever. Right. So I noticed that Franklin has come in there. So again, Frank, I've just why doesn't it work? Yeah, there you are, Franklin. If you could very brief, we'd like maybe your very brief response to today's discussion and Roger's points.
Well, Roger's point is about what's gone wrong with the whole scientific method. So I found it intriguing that there's two ways of going about it. One way you can try and positively prove the theory, and the other way you can just disprove it. So although I wasn't quite clear while I got those points, I wasn't quite clear how that really applied to the whole problem of relativity. I mean, were you saying that those were the problems, that those two guys, is there a better way of doing it? Was there a wrong way? It wasn't very clear to me about what you're trying to say there.
Would you like to deal with that now, Roger, or would you like to summarize the whole proceedings today and include Franklin's question in that?
Well, Einstein has been allowed to not has been allowed to give a theory that is not fully formed. So he wrote a theory, and he's changed his ideas over the years what that theory is. Other people have added extra things to it, and it becomes unclear precisely what the theory is. He didn't write a theory and set it in stone and saying this is definitely the theory. What he did is write things which seem to change where he seems to keep changing his mind about things. And so it starts to become ambiguous as to precisely what the theory is. And if you sort of like saying at the stage where Einstein left it, and you say, well, we've tested that and it doesn't work, well, you've still got the option of still modifying it further on. And so you're in what is an Einsteinian paradigm. And within that Einsteinian paradigm, you are trying to fit your experimental results to fit with that Einsteinian paradigm. And when you do that, you can make changes to what Einstein said, changes to what other people have said after him, and then it becomes it's just an ambiguous theory that you're testing. So you don't know what precisely the theory is. There's nothing written in the text books saying this is the theory definitively, and so without that you can't test it. And so these philosophers who allow a theory to come along and be ambiguous like that, where you can keep modifying it, that has resulted in the scientific method failing, because you then have an ambiguous theory which you can just keep for whatever an experiment shows.
But Andrew Castro says, I'll just put this to you if I may, do these guys know how sloppy Newtonian mechanics was, and how long he worked on it iteratively until the Principia came out? So, this is my question.
Yeah, it
wasn't unique, according to Andrew.
Yeah, there are problems with Newtonian physics. Newton did think about things for a long time, but he brought out his Principia, and that was a book which sort of like set in stone what his theory was. Then he wrote other things further on, and he sort of clarified what he didn't understand, because he had this idea that how would the moon and the earth act through gravity, because it's a force which is not by contact, and so that's action at a distance. So he was making clear the problems with the theory. So that's the way he left it, and he said these are things he didn't know, and in the queries, and he also queried about whether light bent under gravity. So he gave a definitive theory, and he also gave what he didn't know the answers to. But with Einstein, you're starting straight away with him theorizing in a 1905 paper, and then he's theorizing in later papers, and he seems to keep changing the theory. And other people have caught onto that, and they keep changing the theory. And so it just becomes ambiguous theory. It's not set in stone or anything. Unlike Newton's. Newton is a bit ambiguous in places, but at least it's clear if you go back to the sources where those problems are.
Okay, well, unfortunately, the clock has sort of caught up on us. There is a little time, a minute or two, if you want to say anything more before in closing, just about today's proceedings. I know we had the technical problems which Jim Keane was kind enough to say I dealt with to some extent, at least. But so I'm clear about your thesis, Roger, that you do think there's something very, very singular in this regard with regard to Einstein, and possibly it's really somewhat attributable also to what came after him. I mean, a panoply of scientists reinterpreting things and having different ideas, and there being no definitive Bible there that you could sort of go back to.
Yeah, the quantum mechanics is sort of like Einstein sort of set that off as well. So It's an ongoing mess.
Electric effect.
Yeah, it's an ongoing mess,
So
and it seems to be started by Einstein.
Maybe he was not immune to this type of problem. The way he thought and the way he reached conclusions and so on.
But the mainstream, when they do agree that Einstein kept changing his mind, sometimes when you argue with somebody, they say, no, Einstein never changed his mind. But then you can talk to somebody who's actually looked at what Einstein says and compared it to what's now said, and they say, yeah, Einstein did change his mind. When they admit that, they then say, well, Einstein is a genius for changing his mind. For when there's evidence presented to him that he should change his mind, then he's a genius for doing that. So you sort of you can't win, basically. He's a genius for being right, or he's a genius for changing his mind. So this ambiguous way of doing physics he's been praised for doing it. And
there's also the factor, I would imagine, that with classical dynamics, you have sort of, iterative changes, nothing that's completely against all our common sense before that. You say, oh, goodness me, we've now found, how the orbits are dependent upon the inverse square nature, and we have elliptical orbits, conic sections, and blah blah. But with Einstein, it says no. This seems contradictory, and it's against all common sense. And you better change your mind, and you better modify your ideas of common sense. And that's caused, I suppose, a lot of the problem.
A part of it is if you do an education course, and there's lecture notes on these sort of things on the internet now. These lecturers who talk on relativity, they do sometimes admit to the students they're teaching, this doesn't make sense. What they've just told them in a course of lectures, about 10, 20 lectures or whatever, and they admit at the end, oh, this doesn't make sense, but there's no reason for nature to make sense. You've just got to accept that this has been proven by experiment, that even though it doesn't make sense, this is what experiment shows. So you don't win either way. You sort of like, if you point out the theory doesn't make sense, and you get somebody who's in the mainstream willing to admit that, then they're going to say, well, that's how nature is. It doesn't make sense, nature. So you don't win.
Okay, thank you very much, Roger. And if I may, I'll just bring it down for the moment and
thank you.
The meeting. Thank you very much indeed. Well, I think it's been a very stimulating lecture, notwithstanding the technical problems we had initially. And Roger has more than made up for it by, dealing with all those questions. I said initially that it was very revolutionary, that he was saying this is an example of why the scientific method is failing, because notwithstanding all these problems and these reinterpretations, the scientific method, in insofar as it applies to this, is considered stable. So I thought maybe it was quite revolutionary, but I think he's given us a lot of food for thought about the possible uniqueness of our experience with Einstein's relativity in particular, as distinct from, say, Galilean relativity, which predates it by hundreds of years and is generally accepted. We talk about constant velocity effects and no additional fictitious forces having to be introduced, which have to be introduced when you're dealing with accelerated or circular motion, for example. So the other thing we had, apart from this very stimulating idea, is we had, I think, mainly through Nick's good offices, a number of people who joined us, like Vladimir, Stefan, and Alistair. We were able to get Alistair in. There's one other person who left, I think. And anyway, they've given us some interesting ideas, new ideas, ideas which weren't exactly the same as we've been talking about, and weren't the same as the ideas that each one has produced. So we'd like to hear more from them again. But last but not least, I'd like to thank Roger very, very much for having taken considerable trouble. He went through the slides very, very quickly, and he was at a disadvantage, not I, because he couldn't hear what the initial response was. But I hope all of us, will have an opportunity of listening maybe to some of the parts that he missed in the actual live lecture on the recording, and maybe come back if necessary. Roger has, as I say, given us quite a number of talks, and in fact, he's not finished yet. He's offered to give us another one. This time, I think it'll be more on general relativity. Maybe later in the year. Well, it'll be October tomorrow, so it'll be in the next number of weeks. And I did say earlier on that Roger is also he had offered actually some time ago to help me out. I'm a bit swamped with this, and I can only do it every 2 weeks anyway. But maybe in the intermediate weeks, things can be organized, because a number of you have been asking for that, including David de Hilster, by the way. And I haven't been able to commit myself, certainly this year, to doing it every week. But so hopefully Roger will be able to come in and do some of these talks himself. I'll be able to participate as well. And just one thing that occurred to me as we were talking, like these experiments, which ostensibly can only be established by using special relativity. They're very specific, and I talk of them on the small scale sort of things. And as I pointed out to Nick, maybe many of those could be explained by ether effects and having sort of like a Lorentz transformation, which anyway, for my part, I believe are only just quick fixes. It's just an adjustment tool. There's nothing fundamental about it. We can come back to that. But it does strike me that on the larger scale, and this has been mentioned as well, I'm not saying this for the first time, on the larger scale, I think David Hilser maybe has said it a number of times, on the larger scale, we don't use relativistic dynamics. In space travel, we use Newtonian dynamics. And if some of these, here you're concerned with very, very minuscule differences, you'd wreck up complete missions if you're out by small degrees. That doesn't come into it at all. And I noted that in the Apollo 8 mission, which was the first one to reach the moon and orbit it with human beings aboard, on the way back to Earth, the astronaut Bill Adders, he just maybe succinctly said, "I tell you, Isaac Newton is doing most of the driving back." So that was it. He didn't say Albert Einstein was, or anybody else. So thank you very much. Thank you everybody for contributing and participating. We look forward to having you again. I'm seeing, thank you, Ian, and Roger Cornelis has said. Well, thank you very much indeed, Roger. You've been very helpful in giving us all these lectures, and we hope to have you back in the not too distant future. Actually, both as a lecturer and perhaps as a moderator at times. So I'll close the meeting now, and do keep an eye out for the notifications. As I say, we may be able to fill in some of the gaps of the otherwise fortnightly meetings. So keep an eye out and do participate if you can. And I wish you all, wherever you are in the world, I think either in North America or in Europe, a very good day.